everyone, I'm Elsievel.
I'm Charly Mecate.
I'm Teves Rosco.
And I'm Karl Lozada.
And we are Group 5.
Stoichiometry will fall into four subtopics, which are empirical and molecular formula, which will be discussed by Mr. Lozada, limiting reactant, which will be discussed by Ms. Sales, molar mass, which will be discussed by Ms. Rosco, and solutions, which will be discussed by Mr. Mecate. For everything, first, what is stoichiometry? Stoichiometry is the study of quantitative relationships between reactants and products in a chemical reaction. It uses the balanced chemical equation to calculate the amounts of substances involved based on mole ratios, molar mass, and the limiting reactant. This helps determine the theoretical yield, which is the maximum product that can form, and the percent yield, which compares the actual result to the theoretical value.
The empirical formula is the simplest formula for a compound, which is defined as the ratio of the subscripts of the smallest possible whole number of the elements present in the formula. It is also known as the simplest formula. An empirical formula for a compound is the formula of a substance written with the smallest integer subscript. And the molecular formula is a way of representing the chemical compositions of molecule by indicating the types and numbers of atoms present. It shows the exact number of each type of atom in the molecule, but does not provide information about the structure or arrangement of those atoms. Example, water. We know water H2O contains hydrogen 11.1% by mass, oxygen 88.9% by mass. Let's find the empirical and molecular formulas. Assume we have 100 grams of water. Water contains hydrogen 11.1 over 1.008 equals 11.01 mole. And oxygen 88.9 over 16 equals 5.56 mole. So divide by the smallest number of moles. So the oxygen has a smallest mole, which is 5.56 mole. So the hydrogen 11.01 over 5.56 equals 2. So oxygen 5.56 divide 5.56 equals 1. So our empirical formula, the simplest ratio is H2O. Let's find the molecular formula. H2O with the mass of 2 times 1.008 plus 1 times 16 equals 18.016 grams per mole. So the molecular mass of water is also 18 grams mole. So let's use N equals molecular mass over empirical mass equals 18.18016 equals 1. So let's multiply the empirical formula by N. H2O, also our N is 1. H2O times 1 equals H2O. So our molecular formula, our molecular formula is H2O. Water's empirical formula and molecular formula. So let's proceed for another example. Glucose. A compound glucose contains 40% carbon and 6.7 hydrogen, 53.3 oxygen. The molecular mass of the compound is 180 grams per mole. So let's find the empirical formula and molecular formula. So empirical formula, assume the compound's total mass is 100 grams. Carbon 40 over 12 equals 33.33 moles. So the hydrogen 6.7 over 1 equals 6.7 moles. So the oxygen, 53.3 over 16 equals 3.33 moles. So let's simplify. Divide each value by the smallest number of moles, which is 3.33. So the carbon, 3.33 over 3.33 equals 1. So the hydrogen, 6.7 over 3.33 equals 2. So last, the oxygen, 3.33 over 3.33 equals 1. The empirical formula is CH2O. So to find the molecular formula, first calculate the mass of the empirical formula CH2O. So 1 times 12 plus 2 times 1 plus 1 times 16 equals 30 grams per mole. Compare the molecular mass 180 grams per mole with the empirical mass 30 grams per mole. So 180 over 30, so 180 divided 30 equals 60. Multiply the empirical formula by 6. CH2O times 6 equals C6H12O6. So the molecular formula of the glucose is C6H12O6.
Good day everyone. My name is Elsievel and I will be discussing about limiting reactant. So, limiting reactant is the reactant that determines the maximum amount of product formed in a reaction. So, we are going to have some examples to give a much more clear explanation. So, for our first example, assume that you have invited some friends over for dinner and want to bake brownies for dessert. You find 2 boxes of brownie mix in your pantry and see that each package requires 2 eggs. The balanced equation for brownie preparation is thus 1 box mix plus 2 eggs is equal to a batch of brownies. If you have a dozen of eggs, which ingredient will determine the number of batches of brownies that you can prepare? Because each box of brownie mix requires 2 eggs, and you have 2 boxes. So that means you need 4 eggs. 12 eggs is 8 more eggs than you need. Although the ratio of eggs to boxes is 2 to 1, the ratio in your possession is 6 to 1. Hence, the eggs are ingredient reactant present in excess, and the brownie mix is the limiting reactant. Even if you had a refrigerator full of eggs, you can only make 2 batches of brownies. So, for our second example, we have 1 kilogram of titanium tetrachloride and 200 grams of magnesium metal. How much titanium metal can be produced according to the equation above? So, to solve this problem, we have to calculate first the number of moles of each reactant present. And we have 5.272 moles of titanium tetrachloride and 8.23 moles of magnesium metal. And then, divide the actual number of moles of each reactant by its stoichiometric coefficient and the balanced chemical equation. And then we'll have 5.272 for titanium tetrachloride and 4.12 for magnesium metal. The reactant with the smallest mole ratio is the limiting reactant, and magnesium with a calculated stoichiometric mole ratio of 0.12 is the limiting reactant in this problem. To calculate the mass of titanium metal that can be obtained, multiply the number of moles of titanium by the molar mass of titanium, which is 47.867 grams per mole. And then we'll have 197 grams of titanium metal. And that's all for limiting reactants.
Molar mass is a key concept in chemistry that connects the tiny world of atoms and molecules to measurable amounts in the lab. A mole is a large number used to count particles, and molar mass expressed in grams per mole relates the mass of substance to the number of particles it contains. The molar mass of an element is numerically equal to its atomic mass in atomic mass units. For example, oxygen has an atomic mass of 16 atomic mass units, so its molar mass is 16 gram per mole. This concept applies to molecules and compounds as well, but we will tackle it later. For ionic compounds, the term formula mass is used, but their molar mass is calculated in the same way. Understanding molar mass helps chemists relate the microscopic and macroscopic worlds in their work. So our formula for molar mass to get the compound is the summation of number of atoms times atomic mass. For our example 1 is water, which is H2O. So the atomic mass of hydrogen is 1.01 atomic mass unit. So we will be multiplying 2 times the atomic mass of hydrogen, which is 1.01, and is equal to 2.02 atomic mass unit. So for oxygen, our oxygen's atomic mass is 16 atomic mass units, and our molar mass is the summation of both. So it's 2.02 plus 16 is equal to 18.02 gram per mole. So that's our molar mass for H2O. And for example 2, which is glucose, which is CC carbon 6 H1206. Our atomic mass for carbon is 12.01 at atomic mass unit. So it's 6 times 12.01 is equal now to 72.06 at atomic mass unit. So for our hydrogen, its atomic mass is 1.01 atomic mass units, and it's 12 times 1.01 is equal to 12.12 atomic mass units. And for oxygen, it's 16 AMU. So it's 6 times 16 is equal to 96 atomic mass units. For our molar mass, we will just add everything, and it's 72.06 plus 12.12 plus 96 is equal now to 180.18 gram per mole.
Solution in chemistry refers to a homogeneous mixture that consists of a solute, a substance being dissolved, and a solvent, which is the substance in which the solute is dissolved. Solutions can be in any phase, may it be in liquid, gas, or solid form. Some of the most common examples of solution are coffee, seawater, and vinegar. So here are more solutions to give a better idea about the composition of solutions. So first we have our solute, which is the lemon juice powder, with our solvent, which is the cold water, and their solution is lemon juice. Next, we have boiling hot water for our solvent and gelatin powder for our solute, and their solution is gelatin. One of the measures of solution concentration is molarity. Molarity describes the relationship between moles of a solute and the volume of a solution. To calculate molarity, you can start with moles and volume, mass and volume, or moles and milliliters. Plugging these variables into basic formula for calculating molarity will give you the correct answer.
Example number 1. A solution prepared using 15 grams of sodium sulfate. The volume of the solution is 125 ml. Find the molarity of a given solution of the sodium sulfate. Solution. The molecular formula for sodium sulfate is Na2SO4. The molecular mass of sodium sulfate is M is equal to 23 times 2 times 32 plus 16 times 4 is equal to 142. The number of moles of sodium sulfate as per the given question is calculated by the formula N is equal to mass in grams all over molecular weight is equal to 15,142 equal 0.106. Given that the volume of the solution is 125 ml, the expressed to liters, volume is equal to 125 all over 1000 is equal to 0.125. Now using the formula given below, calculate the molarity of the given solution. Molarity is equal to number of moles of solute all over volume of the solution in liters. Substituting the values, we get molarity is equal to 0.0160 times 125 is equal to 0.85 mole or liters. The molarity of the given solution is 0.85 or 0.85 mole or liters.